All right, moving along, and we are now into class 23, and we're going to do part 4 of our dynamic force analysis. Our main goal today is to compare various methods of, the two main methods, MATLAB and SolidWorks, for the different examples we've done. So we're going to do 4 different things. And on Blackboard, I have included the MATLAB files, and I've included a zip file of the parts, and they should be able to open them up once you download them and put them into a folder. And when you're in the folder, you should be able to run it. I'm not sure they have the simulation results, but I think it's all set up. So you just have to hit the little thing. As long as you have motion analysis installed, it should give you the same results that I'm looking at, and you can do the exact same things that I'm doing. And then you can also pick it apart and kind of reverse engineer some of the parameters. So our first one to work on, and I'm not sure this is the best way to proceed, but I'm going to do it anyway. I can't quite get things to open and close right now for some reason. Let me close out of this guy, and I wanted this, and I wanted the other file. All right, so I have that, and so I can make this come over to the side. All right, so I'm going to take a look at what I had to do to adapt. These are the exact same file on the left and the right. I'm going to scroll down, and this is what's uploaded onto Blackboard in terms of notes. To take a look at what had to be changed. All right, so this is the original file, and some of the first things we had to change is we had to change theta 2. This is in order to make this thing, converting this MATLAB, which is made for just a single point, to convert it into a full rotation. I hope this isn't like watching paint dry or listening to paint dry. So we had to change theta 2 because that's going to change as the thing rotates. I mean, it might start out at 30 degrees, but it's going to be going. We're also, because it has an acceleration, so we're going to treat it like a constant acceleration problem. So omega 2 is going to be changing. We get some of the stuff out of the way here for the mass and the mass moment inertia, and then lo and behold, we have the acceleration of g. Right, so we have to do something to change that. So here's our first change, and I know this is pretty small. Let's see, can I make it bigger without going too crazy? It doesn't have, whatever reason, it doesn't have the plus thing that you get, like when you're enlarged. When you're enlarged, you got this guy right here, and you can go back and forth, and you go somewhere in between. Well, of course, now it's just being a jerk. Let's see if we can get this on here. Nah, you almost want to get down to 100%. I guess we're going to 100%. All right. To go 100% of both these, it was 92 before. All right. Yeah, watching paint dry. Listening to paint dry. Exciting stuff. So I had created a string of time that goes between 0 and 1.4 in increments of 0.005 seconds. And of course, alpha, that actually could have been left up at the top because that doesn't change. But I'm going to start with omega O. I said omega O. I changed the name of it right here. It's the initial velocity. And then I had theta O, which is the initial position. And I did this by hand. In a previous, I think it was 2 classes ago, I showed you what my approach to estimating or creating, using kinematics and working backwards to see where I needed to start, so that the combination of acceleration and initial position and acceleration got me into the position that the analysis was previously on, because the single point analysis was when the thing that's rotating, which we really should look at before we go any further, so we can see what it looks like. That thing, right? Right now this thing is stuck because I've put it into that initial condition right here. So if you take a look at that angle right there, and I address that feature right there, you can see It's making a liar out of me. It says I'm coincident to that. Oh, maybe I made the plane. How did I get there? All right, so I'm confused. Did I make a plane? No, here you go. Here's the angle. All right, sorry. Do this one, right? So there was the angle, and I made it 13.94 in between here and here, right? And then when I started my when I created my motion study right at the beginning, I took that and I suppressed that angle, right? So I started exactly at the right spot onto this thing, like right there. I started in that right spot when I was in the model mode over here. But then when I go over to the motion analysis, I suppress it, and it will start in the correct position, right? So we might as well run the thing while it's right there. And you can see it's getting faster and faster, going counterclockwise. And so that was the purpose behind that. So let's go back to this. We were just in here. And that's why we have that degrees. Other things I want to do is I've made a string of time. I don't know how long it is. I could figure it out, but I don't need to figure it out because I can just use this length of that thing command, and I've made I think it's a column. I don't know. Is it a column? Let's go back to there. We did the full rotation, and let's just take a look at the results of this before we go any further. This is what I'm showing here is the torque as a function of time. Right, so we can see that it takes some amount of torque to get started, but then the torque changes direction. Sometimes the motion of the thing is kind of like it's like generating, it's kind of like I guess so you know how you have motors and brakes on your hybrid car, right? I guess it's on your electric car, not your hybrid. But anyway, you're recouping some of the energy when you're braking. So this thing is kind of driving the thing, but then also braking it depending on where it's coming from as you're going through there for the prescribed motion. So when you go into, you take a look at, let me get rid of that so I can just do this right here. Boom. These theta 2, omega 2, f, these are all the same length as that time, which makes nice. And is it a column or is it, so I'll go to theta 2. Boom, oh, it's a row. Okay, so I made a row. But it's initially it's all a bunch of zeros, and then I fill it up. The purpose of that is you could just make, and it used to be standard practice in MATLAB to just create something and just add another item to it and just expanding it. But it changes. They give you a warning. This thing changes length every time for every circle. So, yeah, it's best to start out with a dimensioned on a bunch of zeros and then fill in the blanks as you're going along. All right, so that's something we had to change that was different from in there. I guess I can go back to this. Let's see. So there's several things that are going to take place. You can see that the things that don't get changed is this main matrix right here. But we're going to nest this into a 4. Oh, actually, the first thing I'm going to do is I'm going to do like... is this a position analysis? I think I didn't label this. I think this is a position analysis. Maybe you would consider it a position analysis. No. I'm sorry. This is all you're doing is you're changing thetas. So what we're doing here, we don't need to do a position analysis. Duh. This is simply a rod. But we are populating the theta. Right, so the theta with respect to time at different times is going to be controlled by the initial angle plus the initial angular velocity, which is actually 0, I think, for us, but that's okay. I kept it in there. Times time plus 1/2 the angular acceleration times time squared. So that is a basic kinematic equation that you should be recognized for a constant angular acceleration. And then you can also find what the angular velocity is going to be, right? So here we got the angular position, here we got the angular velocity, with respect to time. So we've populated those two things is what we need to know. And now we make that for end was just to be able to do that over and over again for every time step. And now armed with that, we can have this a piece that's for for a length of t, where we use each for stepping through, we use the position and for whatever reason I decided to make this transition. I guess it makes it kind of easier on a little bit when writing the thing. I'm not sure if it's a shortcut or just a cop-out that I changed the name of theta 2 and this. I could have, instead of putting an OM2, just written omega to n every single time in here, but maybe I saved a little bit. But anyway, you find what the acceleration at the center of gravity is going to be, both the normal and the acceleration, and then you change it into x and y by way of doing just using the theta for the thing. And then we have the position vector. It changes, with position here. So this is not the relative position vector. And then also we have a force that's being applied to that. Is that true? Do we have a force being applied to it? I don't know. Where's the value of this ridiculous force? There it is right there. Yeah, that's the applied external force on the end of this thing. And that gets played right in there. And then we've set the whole thing up, and now we just use the matrices that we had from that previous class. Let's go ahead and open that up, because I don't know why I didn't open that up. And now I got to find it again. Where did you go? I think it is class under notes. And I think it's going to be class. If this is class 23, I bet it's class 21. Yeah. Yeah, so if we went down to this, here's the matrix that we're creating and we're solving right there. So you've already seen this. Here's the matrix, but here's what it looks like, and here's where it came from. And now it's going to want me to close out of the thing. Okay, I'll leave it in there. So we solve that, and then we harvest off of this result, right? We solve that matrix for the unknown forces, and of course it's just a B matrix, or just a column really. And what we do is I give it a names, and then quite often what I'll do is, and I didn't here, is I'll F print the thing out. I don't know why I didn't. I should have F printed out in that piece. Did I just leave? I must have just left that out, because I almost always do the F print thing. No, I guess I didn't hit that thing. I did plot it. I did plot out what. Oh, I guess I don't really want to F print, because it'd be a long string. Okay, that makes sense. But here is a plot of the torque versus time. Great. I think I'm going to go to another video for the next example, but this is going to be pretty similar. Okay. One thing I could do. I'm sorry. I think I left off this little piece right here. I think I could do this. I'll uncomment this, just double checking here. I didn't need these two things, but I want to put this right here. So this is going to assemble the time and the torque together, and then you can write matrix. Ooh, I think I actually need to change this to another command. I think the write matrix doesn't work anymore, or maybe it does. Yes, that's write matrix, right? So they can't call it Excel, but this is what that'll do. It'll create a file. Whoop, it didn't like that. Incorrect dimensions for this thing. Okay, let's get rid of this right here. I think this is the one that's causing it. Now I don't want to fuss around with it. Let's see, will it do this? Yes, it should. Yes, okay. So I got to go to the directory under which the MATLAB is kept, and I do that with examples, and it should have, boom, right there, given me a plot, boom, of, well, it's not a plot, but this is the, we could make a plot out of it, and we could insert a, no, not you, scatter plot, and that guy right there. All right, so that is the solution according to, let's see, here's a little tidbit. If you make a graph like that right there, hit Control X, go back up to the top, hit Control V, boom. Now you moved it. I can't stand moving those things. All right, so hate chart titles, don't want them. Boom. The next is I want to make an export of the SolidWorks. So let's check this thing out for SolidWorks. Come on. Why is it doing it to me lately? Yeah. I don't know. You tell me. Why gotta be like that? I don't know. We're gonna close every damn thing. Oh, there I am. Why is that there? I don't know. Because that's there. Go away. All right. I don't want that. I want SolidWorks. Give me SolidWorks. All right. Alt tab. Alt tab. Boom. No, I don't want you. Go away. Alt tab. Where are you? Where is Pinky? There you are. Okay, so we can show the results of this by way of torque, right? So in why isn't that showing here? I got the motion study. That should be gone. Why is that up there? I don't know. You can go up into motor torque right there. I'll edit the feature. Right, so you can add this in yourself. I should point that out by going here, going by to displacement forces. No, forces, and go motor torque, and then you can pick the motor. What is that thing right there saying? Anyway, it doesn't matter. Okay, pick the motor right there. And pick the component. Now I have this in the XY plane, so it's about the Z, and boom, there is the same graph right there. So you could just look at those two if you wanted to. I already have that done, so I'm going to comment it out. Here he is right here. And you could just look at the two things, and hopefully the magnitudes are kind of in the same range. Yeah, they're kind of in the same range. But let's go ahead and hit our export to spreadsheet. I don't know what that means. Show a add method of workbooks class failed. Don't know what that means. I think I've seen it before. How about we go just calculate that sucker again? Pause. Okay, I figured it out. It looked like I had another Excel open, and it didn't like that. One that I had recently created, so I closed out of that, and it allowed me to do it. Let's see if it works this time. All right, so there you go. It went. So we'd like to combine those two things together. We didn't necessarily have the same steps, and we don't have to. I think in previous videos I have attempted, and it's not letting me jump over to the other video. Let's see, the other screen. There you go. So, but you don't have to. Be good to label these and what they are. So you see that actually the time steps worked out well this time. I probably purposely set them. Let me get rid of this one. It doesn't count. I don't want the large amount of stuff. So in this one, I probably went to my motion study properties, and I used 200 frames per second. So if you go back over to here and you see my string, I went 1/200 right there. So that was, I purposely tried to make them the same, apparently. Me in the past. I don't remember doing it, but I must have. So we can now go ahead and into here and add in, select the data and add in. So if we're going to be good patrons here, there's probably an easier way to do this. I don't remember what it is. Somebody showed me once when you just want to add data, but this is the way that I know once you already have a pre-existing graph to add them together. And so hopefully that's up at the top. And look how close they are. Some of the issues is that there is a resistance to just immediately starting in the SolidWorks dynamic model. It doesn't want to instantaneously have some velocity and acceleration, so it kind of resists it. But you can see how closely these are to each other, and things that I would prefer I think it's stupid to have grid lines in any graph unless your goal is to come back and try to find a point once you print it out that I would like to find out where this point is and estimate where it is off of the graph. That doesn't happen a whole lot, so it's not really a reason to have it there. We should label the axes all the time vertically here, and I often will go in this, I'll call it time, comma, the symbol, and then brackets, and you can write it out if you want to, or just write in the abbreviation for the units. So here we will go torque, comma, capital T, and then I believe these are inch pounds or pound inches. I have always had an affinity of making the length the first thing in torques and moments, because I saw a foot-pound wrench early in my adulthood, and the foot-pounds sounds way better than pounds-feet. Pounds-feet sounds stupid to me, but I'm sure I sound stupid to somebody else. But anyway, things I don't like titles at the top of graphs, because you're going to put it in a paper, and tables have their title on the top. Figures have their title on the bottom. You can remember that by tabletop. That is a convention. Also, things that you might want to get rid of is this stupid border. We'll have no line, because when you go to paste it into a Word document, let's put it into this Word document. See, well, let me open this. This thing is getting angry at me all the time now. I don't know what I'm doing wrong that I can't paste things in here, but let's just paste it in. You can paste it in, right? But now it changes the fonts and all those other things, and that might be something that you would like. I personally like to decide what size it is and proportions and paste special as a meta file into the thing. Although this is belying that, because that's not very sharp right there. It's not very dark. Well, you might consider about coming back in and then going back to the text and seeing if you could make it black. See that? Oh, that did get black, because the text, for whatever reason, was kind of gray. And also the lines are kind of a little bit gray. But anyway, that's just my strongly held opinion. What do I know? Right in there. You might want to make here's something I really, really, really hate. So I'll say this. Really, really, really hate. Never make a caterpillar. No caterpillars like this right here. And somebody puts it in, and they go markers, and they go the built-in markers. That looks so stupid. You look like an idiot. You do that kind of thing. I'm gonna come find you and make fun of you. And then one aspect you might want to consider, because they're lying right on top of each other, is you might want to make one thicker than the other. Right? Let's increase the thickness. It's not showing up for some reason. And then also make it dashed. Okay, so it's not changing now because it just thinks I'm an asshole, apparently. There you go. It looks thick now. Now I'll go down a little bit, and then right there. Boom. See, now you could kind of see the difference between the two. But you also want to do something that I left out, is you would like to, and we need to put it up here somewhere. We could say, what is the first one was MATLAB, right? And the second one was SolidWorks. So let's include on top of this thing, edit this, and go up to here and go to MATLAB. Okay, and then go to that one, edit that one, and go to, yeah, go to that, go to SolidWorks. Boom. So we've named them. But we have to insert legend, so I think we have to go back because we didn't choose it initially, so we have to go insert legend, and not many good choices right here. We'll do that right there, but you could just go ahead and move it, right? So I think it's stupid to have it over to the side, and you don't want to make it too small because it'll do that thing, and you can only make it so big. And then lastly, I personally think that sometimes, a lot of times, it looks kind of dumb to have a different font in this. So you might want to come up here and go to the Times Roman and make all of the numbers into that right there to match whatever text that you're going in. And you might want to try to get the text size to match. And then don't be afraid to click on the and format the space right here. Like, it likes to add a little bit more, but you could increase the amount of clarity of what the point of the thing that you're trying to make to just get rid of a little of that nudge. You could kind of see where they're off from each other, and so that right there is a pretty good graph. Text looks kind of small. Might want to increase it a little bit. Not always to the size of your of the text, but pretty close to the size of the text within your work. And let's see, it can make everything black. Still looks kind of faded to me on my screen. Let's go to the next one after. Let's go to the next video. See you later.